guys, I've had a lot of questions about that first problem on the homework, and I figured since I didn't do anything exactly like this in class, I would at least give you guys a little bit of a hint or a sample problem to base some of the work in that example off of. The main issues people have been coming to me with regarding problem 1 have been what exactly does it mean for something to be speeding up or slowing down? Now, as a refresher from what I wrote down on that homework assignment, here's just kind of a little bit of a side note here. If you're speeding up, so go ahead and write this down. If you're speeding up, what this is going to tell me is that, well, you're going faster. If you're going faster, let's really analyze this in terms of velocity and acceleration. If you are going forward, you want to be going more forward, right? So if you're going forward, your velocity is in the positive direction. If you want to be going even more forward faster than that, you also want your acceleration to be in the same direction. Now, in the opposite sense, if you started out going backward, accelerating forward is just going to slow you down. So if you're speeding up, even though you're going backward, you basically would want to be going more backward. So again, you want the sign of your velocity and acceleration to match. So here your sign, basically plus or minus of both your velocity and your acceleration match. And what that's going to imply is that if you are slowing down, well, there your signs disagree. So let's keep that in mind for this particular question. How do I even get to checking signs in the first place? Well, here's kind of the idea of what you can do to keep track of those signs. I find number lines really helpful for this. So what we're going to do is basically set up a number line representing times. So I'll go ahead and just, call this a timeline for short. For both v of t and a of t. And then once I do this, I'm going to go ahead and compare my signs. Okay, so let's go ahead and get my timeline for v of t going. I'll scroll down a little bit. Okay, if I start out with this function v of t, the first thing that I'm going to go ahead and ask to compare signs, whether it's positive or negative, is, well, when is it 0? Because knowing when this is 0 is going to split up all the other times when I'm either positive or negative. So what I'll go ahead and do is find where v of t is 0, and then mark these points on my line. Okay? If I actually set this equation equal to 0, this t squared minus 6t plus 5 equal to 0. This factors pretty nicely, actually. I'll get t minus 1 times t minus 5 equals 0. So this is going to give me the values t equals 1 and t equals 5. Okay, so I'm going to go ahead and start setting up my number line. I will mark both of those values on here. So this is my number line for velocity. This is going to be 0 at time 1 and at time 5. Now, the reason that I'm going to split up this number line in this manner is the following. If I'm traveling, let's say in the forward direction, we don't usually think of automatically jumping from positive velocities to negative velocities. In other words, I won't randomly be in my car at 40 miles per hour and then instantaneously be going backwards at 20 miles per hour. Not only would that completely mess my car up, but, we have this sense that you have to slow down to be able to change direction. So, if you're slowing down to change direction, that's going to imply at some point you have to pass through a velocity of 0. What that'll tell me in this number line setup is that, well, since we've found all the places that my velocity is 0, namely t equals 1 and t equals 5, those are our places that we slowed down and we may have an opportunity to turn around. We can't turn around anywhere else because otherwise we would have found more zeros. So on each of these intervals here, so this guy going off to negative infinity, this guy between 1 and 5, and this guy going off to positive infinity, each of those 3 intervals, we are either going forward or we are going backward. If I'm going forward on a given interval, I'm doing it the entire interval, similar if I'm going backward. So, let me get rid of some of the clutter here. What I'll go ahead and do then is I know that I can pick a point to test my interval. If I know that I'm doing the same thing on the entire interval, any individual point that you pick from an interval is going to speak for that entire interval. So I can go ahead and pick some sample points here, like say for example 0, 2, 6. I don't have to have picked these. I'm just trying to pick stuff that's in the middle here. And what I'll do is I'll check each of those test points in my velocity function. So v of 0, v of 2, v of 6. Okay? Well, remember, this was my velocity function. Okay, so I don't have to scroll back up again. If I plug 0 into t squared minus 6t plus 5, I just get 5 back. If I plug 2 in, this is 4 minus 12 plus 5, which is minus 3. If I plug 6 in, this is 36 minus 36 plus 5, I get 5. So basically, the signs that I just got were positive, negative, and positive. So if I'm saying that my velocity is positive, that means I'm moving forward. If I'm saying that my velocity is negative, that means that I'm moving back. Okay? Now, let's put this in context with the rest of the problem. I'm going to go ahead and scroll back up really, really fast. I was trying to figure out when we were speeding up or slowing down. Now, what I needed to do to figure that out was, set up a timeline for my velocity function, but also do a timeline for my acceleration function, so I could compare the signs. Okay, we just figured out when my velocity put us in the forward direction or the backward direction. What I want to do is basically the same exact thing for the acceleration function and figure out when that's putting us in the forward direction or the backward direction. So that same process where we set my velocity function equal to 0 to mark the points on the number line and then test the intervals for signs, we want to do this exact same thing but for the acceleration function. So I'll go ahead and note for a of t, we want to find where my a of t is equal to 0 and then basically do the same thing as we just did above. Now comment, if my a of t is equal to 0, well, I need to find a of t. A of t is basically your derivative of your velocity function, so that's what I want equal to 0. Well, my derivative of my velocity function, if my velocity was t squared minus 6t plus 5, well, we could find that my my acceleration is 2t minus 6. And this is something that is pretty easy to solve. We'll just get t equals 3 back. So that point that we ended up with, kind of like before, this is what we mark on our number line. So we'll go ahead and mark my 3. And same deal as before, I need to pick some test points. Let's say 0 and 4. So here I want to pick some points to test in A. Okay. So test in a of t. I want a of 0 over here, and I want a of 4 over here, because those were my two test points. Well, this guy was my acceleration function. So if I plug 0 in there, I'm getting a -6. So that interval is negative. If I plug in 4, this is 8 minus 6. This is 2. So I'm getting a positive. So this is giving me an interval where I'm forward, or oops, let me actually get this straight. This is giving me an interval, sorry, where I'm going backwards, and this guy is giving me an interval where I'm forward. Now, let's actually sum all of that up together, okay? We said, and I'll scroll back up one more time, we needed to compare the signs, okay, up at the top here, set up a timeline and compare the signs, okay, for each of those intervals. So what I'm going to go ahead and do is now come up with a brand new number line where I actually mark all of the information that we just put up top, but this is just going to go all in one place. Alright, so the points of interest here were going to be 1, 3, and 5. Okay, so let's go back and take a look at what our information was here. Now, if I scroll back up, for my velocity function, it was positive before 1 and after 5. Okay, so I'll scroll back down and mark this. Okay, my velocity is positive before 1, and my velocity is positive after 5. Every other interval, though, we're expecting my velocity to be negative. So now I can go ahead and compare this to my acceleration function, which my acceleration before 3 was negative, and my acceleration after 3 was going to be positive. Now we have a pretty clear idea of which intervals my signs agree and which intervals my signs disagree. So here we're going to get that we are speeding up in the negative direction, though. We're speeding up on this interval. Okay, on my time interval from 1 to 3, and also the other place that my signs agreed was over here, this time interval that goes from 5 to infinity.